Hello everyone, welcome back. Now let's have a look over the pressure sensor that will be CPS120, and let's go to the website that will be controleverything.com, and here we have to search on for this particular sensor, and let's see what we got here. And as I command the search option, and it's a digital barometer altimeter, commonly known as a pressure sensor, and these are some of its more prominent features which you are able to see onto my screen. And also you had the option to add to cart or purchase from this very site. I will be interfacing the pressure sensor CPS120 with a BeagleBone Black and using a C code. And to get your hands on the code, let's go to resource tab, and here we have the C code sample onto your screen. You can download the code sample as a zip file right from here. Also, you can get the code from github.com, and the repository there will be Control Everything community. Now let's have a look over the working and interfacing, and before that let's make some hardware connections for that. Well, for the hardware connection setup, the first thing we require is the BeagleBone Black, which you are able to see on my screen, and this here is an I2C Shield for the BeagleBone Black. Now this is available on the website controleverything.com, and the real reason we are using this shield is to make connections easier with other I2C devices. So for that, what we require is to gently place this I2C Shield over the BeagleBone Black and make a connection just like that. For the power up setup, we require two things. The first is a mini USB cable just like this, and gently insert it over here. It is very useful to power up the BeagleBone Black. Now to power up the I2C Shield, we require a 5-volt adapter, which you are able to see on my screen, and gently insert it here. Now for an option for the internet connection, there are two mediums. The first is an Ethernet cable or a LAN cable, and the second is this, a wireless nano USB adapter. Now this here is our pressure sensor that will be barometer altimeter CPS120, and this here is a connecting cable. Now make the connection among the sensor and the cable, and make sure that the brown wire of the cable should be connected to the ground terminal of the sensor, and similarly to the I2C Shield. Now we are done with the hardware connections. Now let's have a look over the code. Coming to the interfacing part, first of all we need to log in to github.com, and here we have to search on for the repository that will be Control Everything community. After getting your hands on the repository, let's have a look over the sensor that will be CPS120, and let's move to the code. But before that, let's have a look over the instructions part, which you clearly see onto the screen, and it says that we need to set up our BeagleBone Black and beaglebone.org. Remember this link will help us to install everything regarding this BeagleBone Black, and do it carefully. After getting this, we need to download or git pull the code onto BeagleBone Black, and this command will compile, and this will run the C code. After getting these, let's go back to the code. As you see, it's a .c extension file here, and in the code you notice that we have included some of the header files here, and in the void main function we will check whether the I2C bus is going to open or not, and then we have to check for the I2C device and whether the address of the sensor is 0x28 or not. Then in the writing section part, we are going to send a start command that will be 0x80, and we are sending the command here, writing part, and here we have a sleep function which delays with 1 second. After that, we are going to read some data from the register that will be 0x00, 2 bytes we are reading for the pressure, MSB and LSB. And after that, we are going to convert the data, and we are using a formula which was provided in the data sheet for the sensor CPS120. At the end, we have the output data to be displayed onto the screen, which you see the pressure is, and the unit will be kilopascal. Now this is the code. Now let's have a look over the working part. Now let's have a look over the working session, and in this part, first step is to copy the entire code as you can see on my screen. And after that, we need to log in to BeagleBone Black, and here we have connected, and here we have to create a new file. .c will be the extension, and here we have to paste it, and then we have to save it. After getting the code, we need to compile it as you can see on my screen, and here we are, and let me compile it, and it's done. It's successfully done. Now to build the code, this is the command, and let's see what we got here. And the pressure right now is 95.04 kilopascal, and when I again run it, there is no significant change. But when I try to press it or put some pressure over the sensor and run the command, you can notice there is a change in pressure. As you can see, it's right now 97.23 kilopascal. When I again run it, the change is reflected onto the screen. There is a slight change. So this is how the pressure sensor measure the pressure. And now what we're going to do is to show some applications and some of the benefits of this sensor. Let's have it. The CPS120 is a high quality, low cost, capacitive absolute pressure sensor solution with a compensated digital pressure and temperature output for low pressure applications such as barometric sensing, portable and stationary barometers, altimeters, weather stations, GPS applications, air control systems, and a lot more. Well, you can have this sensor and you can purchase it from controleverything.com, and you can get the code from resource tab. From this site, you can download the code as zip file. Also, you can get the code from github.com, and the repository there is Control Everything Community. In the end, I would like to make it clear that if you have any doubt regarding any part of this sensor or video, you can have your queries on controleverything.com, and you can post your comments on the community page on this website. For articles and blogs, you can have a look over on instructables.com, and to subscribe more video tutorials like this, you can have a look over our YouTube channel. In the end, I hope you enjoyed this video and had a good one yourself. Thanks a lot for watching.